But we've got a lot to go through. So I'm here to talk about learning microservices with GameOn. Now, quick introduction about myself. My name is Adam Pilkington. It's my Twitter handle if you want to get in contact with me. I work for IBM. I'm a developer down the Hursley Labs down in Winchester Way. I've been lucky enough to work on GameOn over about the last year or so. And the idea of this talk is to share with you our experiences, real-world experiences of trying to use microservices. I see a couple of faces from the previous talk on securing microservices, and that was using GameOn as a reference as well. So you will see a couple of the same slides, but hopefully a different angle, because of course security is one aspect of it that we tackled, which we had our own talk on. This is all going to cover and look at all the other things that we went through and we had to consider. First off, I'd just like to sort of just level set on what a microservice is. You know, people have been talking about microservices for a little while now, and it's just useful just to baseline what we mean by a microservice. Excuse me if I pace a bit, I do tend to sort of walk around the stage. I've got my Fitbit on, so I'm hoping to sneak in a few steps extra towards my 10,000 today by walking around and poking at the screen. So, okay, so microservice is generally something, a function that is scoped around a single business function, okay? So let's just start off by the first thing we found confusing with microservices is the word micro, okay? Micro doesn't necessarily mean small. I mean, by the time you've stood up an app server and a whole bunch of other stuff, it's anything but small. But the micro aspect of it actually just relates to the scope of the business function that you're trying to address. It's very much bounded around a single business process that it does, and it does it well. Typically, the communication is via REST, or for synchronous stuff, or PubSub for async. And it tends to use language agnostic APIs. I mean, this is a polyglot world. Microservices are written in all sorts of different languages, all sorts of different things. But the ability to have a language agnostic API, or a mechanism by which you communicate between the two, is something that's allowed microservices to flourish. You know, you don't need a library necessarily anymore, or certainly you can find a library for your language of choice to enable you to actually start communication between these services. They're also sort of completely replaceable and independently deployed. I mean, they're going to have their own continuous integration tests and a deployment pipeline. And in fact, you know, we'll touch on it a sort of bit later on about how the requirement for you to be able to actually sort of rev a part of your application at a faster speed than another part of it is an indicator that actually that thing could be a candidate for decomposing into a microservice. It's one of those things that, you know, technological choice and speed of deployment affect your decisions, and certainly decisions we made whilst we were developing GameOn as to what parts became their own services, what parts stayed inside sort of the main whole bit. Now, okay, so on our journey, we start there, we have a rough idea, we have a basic sort of definition of what a microservice is. So the next thing we go and do is push the button. Yep, cool. It's tend to, you know, first stop Google. You'll tend to get a good bunch of resources come back. You come through and you see we have Martin Fowler's site here. Lots of good articles. Tells you about sort of how microservices, the theory behind them, the pain of microservices. You know, we'll be honest about this. Microservices aren't free. They're not the answer to everything. And certainly Martin does a good job of explaining the pros and cons and when you should be considering microservices. Then, of course, we can have some books as well. And so we can have a look about how we're going to build a microservice, how we're going to do monolithic decomposition. We can talk about domain languages, about how we sort of convey our ideas about the model. We can talk about the DevOps pipeline. And you start to pick up these words, these terms, Conway's law, about how, you know, sort of the code is going to reflect your organizational structure, eventual consistency, DevOps. There's all these terms sort of buzzing around in your head as you're starting your microservices journey. And okay, so all right, I've got a base term. I've read a few more things. So the next step on every developer's itinerary is a quick stop to Google. And we're going to Google microservices. And typically, this is what you get back. You get back sort of, hey, how to build an API. Hello world runtime microservice. Which is all very well and helps you out. But it only gives you that feeling that microservices are so easy, okay? I've read it, understood it, I understand the concepts, I understand, hey, there's a hello world thing, I can run it. I stand up my microservice, which is probably nothing more than a REST endpoint saying hello world back at you, but you think you're king of the world at this point, you know, things are going swimmingly. And then we're about here on this curve. So we start off at clueless, we've gone up to hey, king, and you realize that's not actually top of the world, because you start to run into real problems. You know, you start to move beyond that. Okay, now how do I actually find where my service is? How do I communicate to other services in a reliable manner? All sorts of things come in, and you start, and there aren't bits and pieces around that tell you how to do it. And eventually, yeah, we're all smart people. You will get there. You'll have blood, sweat, and tears, and some, you know, hard-won experience, but you will come out with it at the end. So, what we did for GameOn is we wanted to let you have hands-on microservice experience. And starting from that sort of simple hello world, I don't need to know too much, bring you into dealing with microservices, let you play, let you have experiment, let you move on, let you tackle the problems that you're going to encounter in an environment that we provide. So what we've done is we've created a text adventure. So what we do is we have an infrastructure, and you go and create a room and you plug it into text adventure. And the important thing about this is it's something that lives all the time. It's there all the time, it's running all the time. It's not something that you'll come along, you know, you can just run 2 minutes in a course, or you sort of download an article, run the thing and finish. This GameOn exists, it's all the time, it's stood up. So you can plug your microservice in, you can go and pick up an advanced adventure, you can read through our tutorials, I think, and you can plug them into an actual proper microservices system, rather than the other tutorials that you have, which sort of just come along and say, okay, you've now stood up, you've got a REST endpoint, you know, that's it, your microservices 101 is done, off you go. Now we're providing you with a structure and a way of doing it, but also we wanted to do it in a fun way. Text adventure, you know, that's right, a text adventure game. And so you learn whilst you're doing as well. So that was the whole reason for creating GameOn. Now, for the people in the previous presentation, the architecture should look familiar to you by now. I'm really test on it. So you, as your initial starting point, okay, you just build a room up the top there. I can't jump up to indicate with it. So you build rooms, okay? It's something that provides an easy conceptual model for people to understand. Okay, if you enter a room, so people who have done text adventures, you go into a room, you interact, you do something in a room, you move to another room. Now each one of these rooms is a microservice provided by a developer who's come along and registered it with our system. So this allows you to sort of conceptually start off by saying, okay, I can understand that. I can understand how people come to my room, interact with me, and I'm a service. My service can come and go. I can update my service at different speeds. I can play with, say, at this point, if I wanted to experiment with a continuous delivery pipeline, I could set that up and still deploy the world's simplest room that just says hello to the person who's entering it. But I'm learning about the DevOps side of microservices because that's what I want to learn about. There's all sorts of options that you can do just by putting and standing a room up. Now, of course, we take care of all of the rest of this for you. But this in itself can be used as tutorials for experimenting and learning about microservices. All of this is in GitHub. It's all open source. There's nothing locked away anywhere. And yeah, we take care of running all this. And if you want to, you can learn about how we did the authentication, how we handle our map things, how we talk to the different databases, how we do the load balancing, how we do the scaling. All these things are there as a further, what we call an advanced adventure for you. So you can start off very simply with a room and then migrate, if you wish to, into looking at how we did for the infrastructure, or concentrate on making your room bigger and better. And by doing so, you start to learn a few more things about microservices. So this is the premise of GameOn. So I'll just take you through what it looks in action. So I'll use screenshots and talk about it. So this is what happens when you log into GameOn. So there's a link at the end of the GameOn website. I've done it. Yes, I did chop it out because I didn't want you all sit here playing an adventure game while I'm talking. But you can, you come in here and here's the first thing, you type in the text adventures. Now, what's an interesting thing we found about making people do text adventures was it found a sort of, it wasn't a barrier to you doing it, because I'm not a front-end developer. I can't do a nice-looking website to save my life. I code. Okay, by taking that out into a text adventure, you don't have to know how to do a Flash front end. You can concentrate on learning how to do the coding. The other thing is it doesn't half force some creativity out of you when you suddenly want to do something, and you're restricted by just having ASCII. So take, for example, we were writing a room that ran on a Raspberry Pi. Okay, that's fine, quite straightforward. Stood a room up running on Raspberry Pi. In the box, we had a PiCam. So we wanted to wire up the PiCam to take pictures, so we could show the picture in the room. except of course the Pi camera generates a normal image. And we've only got ASCII. So what we did was we created another microservice that then converted that image from a normal JPEG into ASCII art, and then we rendered the ASCII art as a picture inside the room. So you can take a picture of a room inside a room almost. And so, that was a really good illustration of us ourselves taking and having a room that we'd designed. We wanted to do some functionality, realized we needed another service. This room was originally in Java. We needed an image processing library, so we went and got that from, I think we used a Node module in Node. So we stood the Node service up, so we passed the image across, got the ASCII art back, rendered it. So you can see how, so instantly even for us, we're seeing how microservices allow us to pick technologies that work and very quickly stand something up. Now I'll come on to the latency and all the other problems that introduced in a bit. So, it wasn't free. We got an image for free in terms of the cost of us being able to bring it on board really quickly, but it brought other problems with it. Okay, so then we come on to what happens when we change rooms. So remember I said each room is its own microservice. In the GameOn world, this whole piece here is someone's room. This is what they're outputting. Now, interestingly for this part of the thing, what we've done is we've actually picked, or actually shown on here, what's known as a sick room. So what the sick room is something, again, that we show in GameOn, which is, okay, so you're there, you're your service, and you're going to reach out, and you're going to want to invoke other services at some point. Now, those services, that service call can fail. And particularly when we're hosting something like GameOn, where people come along and they write a room, maybe it's part of a workshop we're doing, or maybe they're just reading one of the entries on the internet. They stand a room up, they register it, it's all good. But eventually, quite a lot of these rooms fall away and aren't maintained and don't work anymore. So the sick room concept is our way of explaining to you sort of circuit breakers and redundancy in the system. So you learn to expect failure and cater for failure and provide a fallback. So our fallback is we show you a sick room. We've dressed it up in a room. It says it's got a monitor, a chart, and it's making some coughing noises and wheezing a bit and things like that. But basically, each one of these is a retry as well. So we're sort of putting out to the screen as we keep retrying. Eventually, we'll give up and say, you know what, it doesn't seem to be working at all. But it's a sort of way. So we had to deal with rooms coming and going, but it allows us to show how you can deal with rooms coming and in terms of services coming and going. So for creating a room, we have a number of tutorials online. As I said, it's all in GitHub with links into Gitbooks as well. And there are tutorials for writing rooms in Java and JavaScript. I mean, you can write a room in any language you want, as long as you can handle REST requests and WebSockets. Those are your two requirements for being able to write a GameOn room. So once you've created your room, you bring it down. So this is the Java view of the world. Come down, it's very simple. You just package it and build it up with Maven. We're using Docker for containers, and we'll come on to how and why we're picking Docker and containers later on. But in a very grossly oversimplified way for people who don't know what Docker is, just think like a very small, sort of more lightweight machine than the full virtual machine. Effectively, your service looks like, and whatever you stand up inside that container looks to that container, the contents inside that container, as if that's what the world consists of. It's probably the simplest way of explaining what it is. But what you can do is you can sort of poke a little hole in that and share a part of your file system into that container. So obviously, now when you're writing your code and debugging your code, what we found was really good was using volume mappings to be able to say, okay, so a container normally is a static image, except what you can do is you can map in your file system into the Docker container and then run it. So that means for something like some of the servers that support dynamic changes at runtime, if you then go and make a code change to your code and save it in your IDE and it compiles, it can reflect immediately inside the container without restarting the container. So it speeds up the development environment. Instead of having to do a build of the container, stand it up, test it, interact with it, play with it, and something isn't working, you have to bring the container down and rebuild it again with a new cut of your code. By doing this dynamic mapping, you can then actually get these dynamic updates going through. Now, what's also another sort of little trick we found in this area as well was that so the other thing is you want parity between your development and production environment. Docker gives you that. So you have a Docker build file, you set the build file up and everything else, but you want to make changes to it. So we use Docker Compose to orchestrate and bring the files and bring the containers up. But then you have a Docker Compose override file, which does these things like these mappings to your local file system. And we ignore those override files. So that means if you go and check out Docker, you go and check this out from GitHub, and you check this out from GitHub, and you check this out from GitHub, you'll all get exactly the same thing. It looks exactly the same, whereas you could be development, test, and production. Every code that comes down is the same. And then locally, as a developer, you can use the override, the Docker Compose override, to make any changes locally. So it's a useful little tip we found as going through to speed up that, to enable that code sharing that goes on, but also ensure that you've got at least some development momentum behind you as well. Follow our tutorial. It's really simple. It takes about 5 minutes, and you'll end up with a room stood up, and you can go to the endpoint, and we show you that your room is stood up and running. You know, at this point, you can register that room. So obviously, because GameOn's public, you need a public endpoint. So wherever you happen to be, you know, sort of we're IBM, so we use Bluemix. But you know, if you need a public endpoint, come and use Bluemix. But if not, then wherever you are, you stand it up, register that location, and GameOn will start talking to your room. And you do that registration by going through and you go into the game, you fill out a very simple form, basically tell us where you are, and we will come to you. We fill that out, and then you come in here and you'll get a very simple room show up. Okay, and that's it. You know, you have taken that first step. At this point, if you followed the instructions that we've given in our tutorials, you will have actually built that very first simple hello world tutorial, that thing that shows up inside Google that says, if you build this, you have a very simple endpoint that we can call. Except you're in a system now, and people will now, players of the game, will come into your room. So this system is up all the time. So at any point in time, there are any number of players interacting with the world. At any point in time, someone may come into your room. So, you know, it adds that little bit of realism to of interaction. And you can, of course, go in and go straight to your room and interact with it. So in a lot of cases where people want to experiment with microservices, they can't stand up all that other infrastructure. Their IT department obviously won't let them potentially do it inside their companies or whatever. So by coming to GameOn and letting us host the infrastructure for you, but also show you all the code that's making that infrastructure possible, you can take bits of it that you want, but also, as I say, interact with a properly running system. And then, of course, if you make a change to it, like we do here, and we change the description to say, you know, Kate's fun new room, so people in previous talk with Kate will know where I got these slides from. You know, you can see it updated, and we have a new description come through. So we have dynamic updates as well. So GameOn will seamlessly show you a newly deployed room. So you can make your changes. At this point, you know, it's great for testing out your DevOps pipeline, for example. Okay, so I mean, that's from where we came from about why we created GameOn to hopefully how simple it is while we're doing development. But even we learned, as I say, these tips and tricks with Docker, for example, as we're doing development, because we're acting as, you know, our own consumers as much as our own producers of the system as well. And I mean, that's another thing that I'll sort of touch on later on is, you know, when you get to be doing the microservices and the APIs, about how hard it is to get that API right and useful between the services, and how key it is to actually making it correct and useful between the services. I'll say a little bit more about that in a minute. Okay, so I've talked about some of these things. So you have your room stood up now, and you think, okay, all right, that's fine. I did that. I pat on the back, you know. But what do I do next? And so this is where we start to challenge you to think about some of the issues that you're going to have to deal with microservices, as well as some of the fun things like grabbing a new piece of tech and standing up really quickly. There are other issues and considerations. So, you know, go into the game and play the game as a user. And you'll notice the latency as you move around between the rooms. And this will be because services now, in the old world, everything was in your monolith. So you went in and you called something and it all stayed in process. It was all there, ready access, and was pretty fast. Now when you come into microservices, you're more than likely going to be calling out either to other services or other services are calling you. And you're introducing network hops and latency. So the first sort of takeaway from this is it's not going to, you know, in a lot of cases go as fast. For example, you know, there's going to be some latency because you are introducing those hops. So, you know, benefits, I can get new services up and running, I can pick new tech. I now have new hops, you know, it's more latency. And also, you know, it brings back to these fallacies of distributed computing, which came out, I can't remember who who put them out now. It's on end of the 90s. And basically it brings back a lot of the issues that people have forgotten about distributed computing. They got used to doing the monolith. They got also used to assuming that latency is 0, bandwidth is infinite. What are a couple of ones that are in there? Things don't change, nothing fails, networks are heterogeneous. There's all sorts of things in there that relate to the monolithic way. You know, we've thought about applications, and that microservices now, if you continue to think about those ways, your microservice is going to fail. You know, you're going to assume that REST call you've made is instantly going to come back, rather than assuming, well, first off, let's assume it's going to fail or take a long time. Actually, now, how did I find that service to call in the first place? These are all the things that microservices bring to the table that you have to consider. Now, what we've done is, you know, we've written some tutorials about this. We've got some entries in the Git book that explain how to deal with this. So other questions that come up when you're doing this is what next, now that you've got your room together, is how do you scale it? So scaling is interesting because, of course, a lot of the time you think there's one thing. So say, for example, I write a room that's got a table in it and it's got a vase on the table. And I bring another room up because I want, okay, my room's so popular, I need 2 of these things because that vase is getting a lot of people to come and look at it. So you have 2 rooms with 2, well, do you have 2 vases? Or do you have 1 vase? And if you have 1 vase and I take the vase, how do you tell all the other people in the other room that I've taken the vase? So now you start to deal with, start to think about things like eventual consistency, whereby, you know, updates in one place have to be reflected in other instances, and how you deal with things like that. So, you know, and where are your players? Is another good example. So, you know, these days you're writing, particularly if you deploy a microservice into the cloud, for example, you may have people accessing it by mobile phone, by their laptop, by whatever. But that can also be the same person that's accessing it. So it's no longer like this is a different person. This is the same person, but coming at it from different places. So again, we challenge you to think about these things in your room. Now, we have some answers because we have to deal with, so inside the GameOn, and this is perhaps where you start looking at how we've handled the fact that when someone logs into the GameOn system, we know if you're the same user, whether you've come in from your phone or whether you're coming from your desktop. So those answers are in the code, and we have walkthroughs there. But this is sort of setting the scene about why you might want to come along and actually build a room. It's not as, it is like microservices in itself. It's like, it's a lot simpler than potentially it can end up being. You know, it starts off being a nice simple, I'm going to put a room up to. The moment you start to do things, we're trying to put right in front of you what it means to be in microservices. So let's have a look at the service composition. So these are the things, these are the steps we went through. First off, this, I mean, as a quick preview forward, that's what we ended up with, but we started here. Okay, so we started off and we decided we were going to have a player service that handled the players. I'm largely going to ignore the proxy at the front because that's just transparently passing or routing traffic through. So we got a player, we got a database, which was Bongo at the time. We had a concierge, and we got our single room at this point that we'd written, and this was pretty much all locally developed at that point in time. And the idea was that a player would come along, they would go, we had a hotel concept in our head, and the idea was that the player would come along, they would come into the hotel, they would go and talk to the concierge, and the concierge would give them the keys to a room, basically just tell them which room to go to, and then they would go to that room as well. And that was our basic sort of model that we were working with as our first pass. Except that we started to realize that we had a few problems with this model. Now, first off comes back to sort of the domain-driven design. Now, to paraphrase, the US and the British are, you know, 2 nations separated by a common language. And nothing is more true than trying to come up with a model that's something like a concierge, and working with our colleagues in the US who hadn't the faintest idea what mental model we had in our head, didn't know how to interact with the concierge service. So confusion reigned. They didn't understand the APIs, they didn't understand the mental map we had of how people would rock up to this hotel and take a key. I can't remember what they thought, how they thought it was going to work, but it certainly wasn't the same way the team in the UK thought it was going to work. So, I mean, this is the thing, a microservice in a purist world, we can sit there as a microservice provider, you can sit there and write a microservice. It's independently deployable, doesn't rely on other people, or if it does, it's, you know, if it relies on other services, they're wrapped with fallbacks and resilience. And I'm free to deploy that. But if other people don't understand how to use your service, that service is going to fail. Okay, and we didn't have people who understood how to use our services. The other thing we had on here was that our player service. So the two things on there at the moment is we have both HTTP stateless, short-lived traffic calls going into player. We also have long-running WebSockets running through player as well. So we were going to try and scale this up because, say, for example, we wanted to, maintain, either we wanted to handle more of the HTTP traffic, we'd be dragging up a whole load of WebSocket stuff as well that we didn't really need. Player was doing too much. And the other thing inside Player we had was we had Angular front end as well, reactive web for the users to see on the user interface. So that was embedded in there. And the thing with that is that we wanted to make changes to that quite quickly. And although we had a DevOps pipeline for deploying the player, we were still basically deploying the player every 2 minutes because we wanted to make a change to the UI. So that kind of, I mentioned it earlier, that tension where you have what isn't that far off a monolithic application here, to be honest. We've got two things that are doing quite a lot of stuff. We were finding that one aspect of that, one functional area, needed to deploy, needed to rev faster. So it's a good candidate for splitting out to its own microservice. So we found that, it's one of those indicators that people talk about, but we experienced it firsthand. We wanted to spin out that front end much faster than we ever wanted to make updates to player or that whole player service. So that's what we had. And then this is what we migrated to. So largely, just a thing, these bottom sections with the Elk stack, CouchDB, Kafka, and Amalgamate, I'll talk a little bit about later. But they're really what we term our platform services. So they are service providers, services that realistically that GameOn uses, but doesn't expect you to interact with in terms of writing code for, or making pull requests to, or actually deploying new stuff to. When we run locally, we bring up, we don't do the I can't remember the step, but we certainly bring up a local Couch, Kafka, and Amalgamate for you. But it's very much inside Docker containers, scripted away, composed away. You don't really deal with it. You're really either dealing with these other layers of services or your room itself. So we split that out. So this is what I end up with. So we split out our static Angular front end out. This allowed our front end developers to work on the UI and to put new UI changes in very simply and easily. We split out the auth service. So this is where was covered in the security talk, but this is where our authentication happened. So what we wanted to be able to do, originally we started by maintaining our own set of usernames, passwords for about 30 seconds till we realized that we really didn't want to be in that game anymore. So what we did is we split out our auth service so that you can use that wherever you want, and that's the thing that provides social sign-on. So inside there, if you want to know how to authenticate using Google, Facebook, whatever, there are, of course, plenty of examples on those websites. But this is one that's actually deployed inside a microservice that's then passing that token on to other microservices for them to validate against and to use. So again, GameOn is about providing that whole view of how things you want to do actually work in the real world, actually do it. So we split the auth out. Map and player. So now we switched to CouchDB. The reason for that was our deployment choices. So originally we started off with a Mongo database, nothing wrong with that. But when we came to want to do our cloud deployment, we wanted to use our Cloudant instance inside our Bluemix offering. So basically Cloudant and CouchDB allow us to use the same sets of libraries to interact with that database, so we maintain that development production parity. So there's no difference between data access that occurs when we run. You can run instantly. If you go to the GameOn site and go to the main part, you can run all of this locally in whatever that is, 10 Docker containers that'll all spin up on your machine. So we've gone to great lengths to make sure you can run the whole thing locally as well as in the cloud. Because when you're developing, one of the things So we said is if you take the purest sort of microservice view, is you are master of your own destiny. You can do what you want. You can change what you want. You can redeploy when you want. Quite often, we were finding we were only doing that because either we wanted to make another call from somewhere else or someone was wanting that functionality. So quite often, we were changing 2 services at the same time. Or say at the same time wasn't, conceptually before we said we were done making that change, we had altered 2 services to either accept or pass the new parameters through, or they were coupled at that sort of conceptual level for us to say, yes, we've added, I don't know, whatever function it happened to be. And if you take that view, then you can't work in that kind of isolated thing. So to be able to run the whole thing locally lets you do that kind of testing and development locally without having to push one up into the you push it up, and then you find the person calling you didn't expect you to change something. Now, you shouldn't issue breaking calls, and versioning APIs, we quickly realized is important. So if you're not doing it when you get to microservice world, the first thing you want to do is version your APIs. You want to make sure you're calling it V1, whatever, V2, whatever, or something at the front, because very quickly you'll have other services binding onto that and talking to that point, and then you want to change something. Now, with JSON, XML, or whatever you're passing across, so, if it's not a breaking change, it's adding stuff to it, the other callers should cope with it. But at some point, you're going to want to make some sort of breaking change. You want to get a version 2 of your API. So we quickly retrofitted versioning to our APIs not long after we started doing all of this. The other thing is we put in Kafka as well so that we could start sending out message events. So that, again, we don't really want, so player, say someone enters a room, we didn't really want that service to have to know where all the other services are, or an endless number of services to tell you that something's happened. So we move to eventing for that. So what we do is we publish an event into Kafka, and then whoever's interested can subscribe to that event. Similarly, when you register a room or unregister a room, now we do have an interactive map that can pick up changes. So this sort of introduction of eventing lets you handle that sort of, how do I let a whole bunch of other services know that I've just done something without knowing how many other services care that I've just done that, to the messaging. And that's it. So that's where we were with that. And finally, map. So this was we threw the concierge out, sacked him, got rid of him. The analogy wasn't working. People didn't understand how to do it. So we changed the name to map from concierge. Suddenly it became clear this was the map for the GameOn world. We were working much more like a sort of old school adventure game. We ditched that hotel mind concept that we were working with originally, and we went to having a map. So that was the map system. And I've covered why we changed over our databases. Okay, so 12 factors. So people who don't know the 12-factor applications, basically, these are the guys at Heroku who have sort of put down these 12 characteristics of software that's just going to act as a service, microservice. Okay, so what we've done inside GameOn is we've followed wherever we can these 12 factors, and that has immeasurably improved our ability to quickly deploy stuff and actually get those microservice benefits without going back to might as well have had a monolith. So I won't go through these in any depth because you can go to 12factors.net and read them. But I will draw parallels between what we've done in GameOn and how we adhered to the 12-factor rules and how it helped us. So inside our Git system, we have Git and submodules. Now, possibly a contentious choice there. There are lovers and haters of Git submodules. So basically, the reason we went for Git, Git, first off, all your microservices have their own source code repositories. You don't share source code anywhere. You can share libraries, and I'll come on to how you can do that in a bit, but you don't share source. So you have your own GitHub. But the thing is, when you're doing GameOn, particularly when you're a GameOn core developer, like we're on the platform services side, it's very often not enough to bring down the one microservice you want to change. I've already talked about this. So I'm making a change. It's likely because it's going to flow through and be called by a couple other services. So submodules let us basically say, okay, you go to this one Git repository. If you git clone from here, you'll get out everything you need to stand up that whole system. okay? And the submodules just peg these other repositories at certain commit levels for you. So you have like this meta view over all your other repos. If you go to the GameOn GitHub, I think there's about 30 repositories in there. Not all of them come down as part of this Git clone. This is real just the core stuff, but there are lots of rooms. There's rooms that run on little chips. There's rooms that run on remote control cars. There's rooms that do all sorts of things in there with the modules. So this, and the way we got the submodules to work, so the submodules bit that becomes problematic is how do you update the pointer in the top repo to say, okay, we're now at a new commit level over here. And we put that onto our DevOps pipeline. So we don't let people change the commit level on the submodules. We have the automation and the tooling do it. That way you don't get into this thing where someone delivers some code, comes in and says, okay, I'm just going to rev that submodule. And in fact, there's something wrong and they back it out, forget to change the submodule, things get out of sync or whatever they're doing. You let the automation do it, and we've found that tends to keep away the worst of what the problems people have found with submodules. We think the ability to go to a single repo and git clone out or whatever a working full system of the core service you need outweighs any problems that we're going to get with the submodules. So it's a way of organizing your code. Already mentioned we're using containers. I mean, this gives you quite a lot of the 12 factors. So containers let you declare your dependencies. You're sitting there inside your build file. You're telling it what it needs to be able to run. You have a definitive build, release, run phases. They aren't mixed. There isn't one that does everything. This is the build one. This is the release phase, the run. We have everything scaled up at separate processes, and the main thing is you have that development production parity. So you don't have that issue where you had before, where you do something locally in the old way of doing things. You develop something locally, you'd finish, you chuck it over the wall to the ops guys to deploy, and they come back and say, done work. And you go, well, works on my machine. And they go, well, done work here. And you carry on. Whereas the use of containers all the way through lets you have that development, dev production parity. And the other thing is you have independent pipelines to deploy our containers as well. And I've talked about the overlays for editing. Okay, so I work for IBM. I'm a Java developer. So we use Liberty, WebSphere Liberty, for our Java runtime. So that's why we use that Java runtime. It's not common in any of the others, except of course that we can use some of the things that Liberty gives us. So what we have with Liberty is a componentized runtime. So you can declare exactly what JEE features you need in your code. Now what becomes interesting then is when you combine that with Docker and its ability to cache your Docker files and the layers inside that Docker file, it means we can actually end up with a cached base JEE runtime, such that the only variance between containers is the WAR file itself. So then when it comes to doing deployments or builds or standing up new instances of one of our services, because everything is cached, Docker only has to just build that, whatever it is, 1 meg of WAR file you push out there, maybe, something like that. And that's all and that's also what you also need to deploy. So it becomes really quick and to deploy these. So one of the things you're looking for is to optimize around your Docker caching, such that you can do this so the build and deploy stage is as painless as possible. The other thing we do is we take config from the environment. So although we talk about dev and production parity, they aren't exactly equal. Take, for example, it's CouchDB running locally and Cloud when we deploy to Bluemix. So how do we do that? Well, what we do is as we stand up our containers, we inject in as environment variables the configuration you need to run in that side of the container. So we provide configuration injected into environment variables. And just here I have an example of how we read that out into our Liberty configuration. So when you're running locally, you can have a username and password injected into the environment. And when you're running in your DevOps pipeline, the pipeline injects the real one. Now the other bonus of this is that when you're committing your code into GitHub, you can commit one in here that has an environment file for development that has got user as guest and password as password, because that's what your local CouchDB runs against. And you can commit that to GitHub. You can share that with people, that's fine. Obviously, you can't share your real credentials with anyone. So when you go into production, you use your pipeline to inject those values into the environment, and you get the production values come through. So again, you can share code. The code is the same code that comes down that all the developers are working on. And it's the same code that gets put into production. You inject configuration through the environment. So security. So again, for people in the previous talk, there's the same sort of slides, but this is how we did the OAuth authentication between us and Facebook. Now, at a very high level, person comes in, we send them off to Facebook to authenticate whichever one they pick. It comes back. They give us the little opaque token they got from Facebook or whatever. We then go back to Facebook with our special token that proves who we are, and we say, you know, is this a valid token? And then tell me about the user, and it comes back. And Facebook, because we check out and the token's keyed to our key as well, we get the information back in. We then create a signed JSON web token we pass around. Now, what's the interesting part is we actually store that token on the client. So there are a couple of aspects in here to go through. The first off is that when we send people out to Facebook, we give them our public part of the token. So anything that you pass out to the client is totally untrusted at that point. So by doing this mechanism, we can share with the client our public part because they give our public part to Facebook. Facebook does some things that is keyed to our private key. It comes back, comes over. We've got our private key over here. We can send both of those back to Facebook to prove who we are. Comes back, and we can get out to find out your email or whatever you said we could have access to. I think we only asked for email scope, so we can log who you are. The other thing is if you pass, so when we put it into the JSON web token, we sign it. So the digital signature means that, and we sign it with our own private key. It means that you can't alter that. What's put in that JSON web token without us knowing that you've altered it. So you know this is a text adventure game. So it hasn't got any stuff we don't want you to see, but it's got things in there we don't want you to change. But by giving it to you, what it means is if you're running a browser session or long running, you can come back 20 minutes later and we're still on that JSON web token because we've checked that you haven't changed it. You haven't changed it. You're logged in. You're this user. We'll put you back in this room. This is where you were. That's how we know where you are. And that trick of giving someone a signed JSON web token and consuming it back is a good way of, is coping with that long-running nature or asynchronous nature of microservice calls. Another example of that is when we were authenticating with GitHub, for example, when we wanted to be able to write code into your Git repository. When we redirect you off to Git to ask for permission for us to access your repository, we were allowed to pass. The original problem was we would go off to Git would call us back, and it would be in a different instance that made the first request because we have multiple instances of that back-end service running. So this one made the request, this one got the response. They weren't talking to each other. So what we did is we put a signed JWT into the request that went up that had an ID in it that we could reference. That goes up to GitHub. It comes back down. GitHub will pass you back that as the thing you passed along. It doesn't matter what service it turns up in. We can validate that it hasn't changed. We can then go through and process your ID. It doesn't matter which service. That ability to pass out signed JWTs via a key that you control internally. So you don't even need PKI at this point. You don't need an infrastructure to this. This is just a way that we found of passing the things around. We also did some message authentication. So this is where we basically hashed all of our parameters. This is a service-to-service call problem where you want to make sure signed JWT will tell you who that person is. The message-to-message, if you is hashing and signing or encrypting the parameters, tell you they haven't changed the parameters on the request or the HTTP headers. One deals with user identity, and the other one deals with service trust. And we did this, we put this into a shared library. Now we use something called jitpack.io. And what that allows you to do is you can point that at it's a service that runs out on the internet. You can point at any public GitHub repo and make that a dependency in your project. And Jitpack will inject those dependencies and everything it needs into your build file at runtime. It acts like another repository. So what that means is you can develop all your code in one GitHub repo, treat it like a shared library, inject it into your other services. And that's what we did with our security. Service discovery. So this is going to talk a little about the amalgamate. So when you want to find out where your services are, you've got a couple of options. You can either go through and know where your services are, hard-coded, but that's going to break. Things change, services move. So you want service discovery, and you can either go direct to a service registry via a client library inside your process, or you can go via a sidecar process. So this is something that sits on the side that basically intercepts your calls and then routes them off to the right place. So I'm well aware I am running up against coffee time. So I'm just going to jump to this one because we're nearly done. So we use something called Amalgamate. This is open source. If you go to amalgamate.io, you can read all about it. And this runs as a sidecar process, as I said. So what happens is when your injected configuration comes in, it goes to localhost port 6473, I think, and then the service name. And what happens is the Amalgamate side process intercepts that call, looks it up in its service registry of other processes that registered, and then routes that on transparently. Now, there are a couple of advantages of using this process. First off is if we want to change how we do this later on, the sidecar process means we don't have to do any code changes. We can change our service proxy however we want. The other thing about Amalgamate that's quite interesting is it does content-based routing and version-based routing. So what that means is it will do routing based on HTTP headers and URLs. So that means you can say, well, all my iPhone users go to this service, and all my Android users go to that service. All completely transparent to your clients. You just get stuff. Or version routing. So service A, when that's talking to service B, goes via this one route. Version goes to version 1. When service A wants to talk to service C, it gets version 2. So it does version routing. Now, combining those two up does let you do some good blue-green deployments and failure testing as well, because what you can also say is, okay, simulate 10%, a whole bunch of failures to this service and check the calling thing actually handles all those failures without taking the service offline. And then you can bring it back online by just letting the calls go through. So it's completely transparently to your services. You can do lots of failure simulations. And that's a really good way of testing that you've actually coded for stuff in the microservices. So just to wrap up, how successful were we? Well, we've done lots of rooms. It's a picture of me. I managed to even get on the telly and driving a car, because we managed to get a GameOn room inside a remote control car. So you would go into the room, you'd pick the steering wheel up off the table, and you could go forward and back and left and right and drive the remote control car on the floor. So that was wiring a whole bunch of cloud to on-premise connectivity and everything else. But it was, it allowed us to show how to do that and explore those concepts. This is a map room, but done in ASCII art. So we did lots of rooms. We've had lots of people outside of IBM want to get involved. We have a public Slack channel you can join up to. It's all open source. We have people looking at converting the graph to the map database to a graph database. And all sorts of other people come along with ideas and want to talk about it, and we're completely open in there. And that's it. So that's where you can find it all. Here's my contact details. I'm quite happy to answer any questions now. More than happy if people haven't got any questions and don't want to hear any, they shoot off for their coffee. Or any questions? Wow. I'm not sure that's good or bad, but I'll be here for another 10 minutes or so if people want to come and ask me anything, or I'll be around for a while for this afternoon. But thank you very much for attending.